Hello everyone, today we are going to talk about the operating system assignment 3, which is a scheduler that's making by our group. First of all, let me introduce about the HRN system. The higher response ratio priority scheduling algorithms is mainly used for job scheduling. The algorithms is a balance between the FCFS scheduling algorithms and the SGF. We'll consider the waiting time of estimated running time of each job. Compare with the scheduling algorithm provided in the baseline.cpp, the total waiting time of high priority and the low priority customer, the total waiting time of customer, the longest response time and the number of customer switching time has been significantly improved in 5 aspects. Our purpose of the to priority the program, we think in the HRRN after assigning a priority to each job, the priority is always unchanged, so it is somewhat unreasonable. Because of this, low priority jobs may never be excluded. In order to solve this problem, the HRN algorithms calculates the priority of the job each time. Okay, let's move to next part is our coding part. First of all, we create an int type array, which is named at arrival ID with the capacity of 1000. The purpose of this array is to store the customer IDs. The reason of this capacity of 1000 is far more than the number of customers, so that the ID of each customer can be stored completely. However, we think it has disadvantages. For example, the number of customers exceed 1000 and the number of customers is small, which take up space. Second, we create a variable location of type int, initialized to 0. The function of the variable is to record the ID of customer that arrival at the current time. However, we have found some disadvantages also in the number of customers exceed the range of int. Then we create a getKeyR method. This purpose of this to calculate the ID of the customer with the highest corresponding ratio among the current arrival customers and return it. Then I want to say interesting things. We have facing a bug and it confused our a lot of time. At the beginning, we used the equal sign and find that there was a bug in the operation. Then we find because that is reason that is because that there are two jobs arrival at the same time. That makes the current time was the same with the arrival time. That will make to only one job will be run at that time. So then we use less than or equal to solve this problem. Okay, let's move to next part. The first for loop in the calculate of the response ratio. First for loop, first judge whether the customer I was arrived, and if it has not arrived, continue to directly see the next customer. If it is arrived, it depends on whether the variable which names at SLOTS remaining its remaining running time is 0. If it is 0, it means that the customer does not need to run anymore to skip it. If it is not 0, start to calculate the response ratio. The calculation form of the response ratio is that remaining running time minus waiting time divide remaining running time priority multiplied by 10. Then the last if statement is to record the highest response ratio under the corresponding subscript ID. This part, it should be the MIRR, should names as the max RR. The name was not good at that time, but it doesn't affect the program, so we didn't change that. Okay, so let's change to the second for loop. It is up to the remaining running time of the waiting time. First of all, the first of the statement is used to determine whether it has finished running or the customer who was not yet arrived. If yes, just ignore it and continue to see next customer. If not, just look at next statement. Determine whether it has the ID of the highest response ratio last obtained in the last for loop, that is the customer. If the answer is yes, add 1 to his remaining running time, and then add 1 to waiting time to other customers. And then we have checked the result with the data1txt using the for loop accumulate time until the end of all the visitors has stopped the program. And we have make sure it has been significant prioritized, and the same situation result in the TXT2 to 5 as shown in the PPT. It's good. It has been good significant priority. And okay, let's move to next the conclusion part. In the design of the scheduling algorithms, it can be seen from the experimental results that although most of requirements has been met, it still need to solve the problem of how to run the arrival time when the customer ID equals 0 and the priority is 0. And thank you for listening. That is all for today's presentation.